Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are indeed going to say it right. The topic of the day is calculus again, and this is increasing and decreasing functions part 3. We left off right here with this wonderful curve, x cubed minus 3x plus 4. We made a nifty sign diagram showing where the function was increasing, where it was decreasing, and where it was increasing again. And what I want to do before we move forward is again re-emphasizing where the changes took place. From here, we are increasing, and then all of a sudden, we are decreasing, and then all of a sudden, we are increasing. And what I want to focus on is the derivative, or the slope of the tangent to the curve. Those changes took place when the derivative was equal to 0. Slope of the tangent to the curve was 0 here and here. Okay? So if we don't have a curve, if we don't have the graph of the curve, I should say, we can find where a function is increasing or decreasing by taking the derivative, setting it equal to 0 to see where the increasing and decreasing is going to change on the function, and then doing a little test. Okay? Now, in order to do that test, we have to understand that on an interval where a function is increasing, the derivative is always, no matter where it is, going to be positive, because the slope of the tangent to the curve, which is the derivative, will always be positive on the increasing part of a function, and it will always be negative, look at the slope of the tangent to the curve, on the part of a function that's decreasing. Okay? So let's put that to practice here. We are going to find the intervals where the functions are increasing or decreasing without being able to look at the graph. And we are going to do that by taking the derivative and setting it equal to 0 and then doing a little bit of a test. So the derivative of this function would be negative 3x squared plus 6x. Okay? Now remember, we're going to have a change, if there is going to be a change, from increasing to decreasing or decreasing to increasing of a function when the derivative, the slope of the tangent to the curve, is equal to 0. So I am going to set the derivative equal to 0 and solve to see where the slope is 0. When does this happen? I can factor out a negative 3x here. That leaves me with x minus 2 equal to 0. And solving, I get x equal to 0, and I get x equal to 2. So I can start my sign diagram right here. Okay. And I know that my critical points, we call these points critical points. They are 0 and 2. So if there's going to be a change in increasing and decreasing, it will happen at 0, x equal to 0, and x equal to 2. Well, how can we tell? Well, this is sometimes referred to as the first derivative test. And the first derivative test can tell us where a function is increasing or decreasing. Remember, here's the key point. If a function is increasing, then the derivative is positive at all points on the interval. So no matter what value of x I chose here, if I substituted it into the derivative function, the result would be positive. Okay, so let's go back here and let's choose a point. Let's start with something easy like the 1 here between 0 and 2. I'm going to choose the point 1. I could choose any point I want in here, but 1 is the easiest. So I am going to find f prime of 1. And that is going to be equal to what? Negative 3 plus 6, which is positive 3. I'm writing a positive just to show, oh, the derivative is positive on this interval. The slope of the tangent to the curve is positive, same as the derivative on this interval. Therefore, the mother function, f of x, is increasing on this interval from 0 to 2. Okay? Now, I don't care about the 3 really. I care about the sign of the 3, whether it's positive or negative. So now I'm going to choose a function or a number, a value for x on another interval. So to the right of 2, I guess the easiest thing would be 3. So f prime of 3, we're going to do a lot of this in my head. That's going to be, let's see, a negative 3 times a positive 9 is a negative 27. Let's see, plus an 18. Clearly that is going to be negative. I don't care about the value. I just care whether it's positive or negative, because that tells me that it's negative on this entire interval, which means the function is decreasing to the right of 2. And finally, I'll choose this interval over here. I guess negative 1 would be the easiest choice. So f prime of negative 1 is going to be equal to, let's see, negative 3. Negative 1 squared is positive, so that would be a negative 3. 6 times negative 1 and a minus 6. It's going to be negative. I don't care that it's negative 9, just that it's negative. So I know the function is decreasing on this interval. So I know the function is increasing, f is increasing, 0 less than or equal to x less than or equal to 2, and it's decreasing, negative infinity less than x less than or equal to 0, as well as 2 less than or equal to x less than or equal to positive infinity. Okay? And I have this all queued up and ready to graph. Or not ready to graph, it's already graphed on the Inspire here. That is the original function. And we said that the graph was decreasing from negative infinity to 0. And you can see that the slope, no matter where I drag the tangent line, is negative while the function is decreasing. Then the slope goes to 0. And so there's a change, and it becomes positive. The derivative becomes positive. And I keep switching around what I'm saying just to drive home the point that the slope of the tangent to the curve, that value is the derivative. So here the derivative is positive, and so the function is increasing between 0 and 2. Then it goes to 0 again, and we have another change. Let's make it 0, 0, 0. I can't do it. My hands are too cold. 0. Ah, yes, 0. No such thing as negative 0. The computer can't handle it. And then the derivative becomes negative, so the function is decreasing from 2 to positive infinity, which is exactly what we wrote right here. Okay, let's try another example. 3x to the 4th. Let's see, let's get this out of the way. Give us some working room. Minus 8x cubed plus 2. So we're going to take the derivative, and that is equal to 12x cubed minus 24x squared. To find my critical points, I'm going to set the derivative equal to 0 and solve, and then I'll do my test. So let's see, I can factor out 12x squared, and I'm left with x minus 2 equal to 0. So again, we have our critical points at x equal to 0 and x equal to 2. That is a coincidence. Don't you worry about that. And so my little sign diagram here, okay, and my critical points are at 0 and 2 again. Okay, so since we know what we're doing, I'm going to start to the left and work to the right. I'm going to choose negative 1. Oh, okay, so I'm going to find f prime of negative 1. I thought I messed up there. Okay, and that's going to be equal to negative 1 cubed is negative 1, so that's a negative 12 minus 24. That is definitely going to be negative. What about f prime of 1? Well, that would be 12 minus 24. That too is going to be negative. You might be thinking, hey, how come it didn't change? Well, it doesn't necessarily have to change. Okay, and you'll see that on the graph in just a second. And then what? 3, we'll try f prime of 3. Is that positive or is it negative? So 27 times 12, that's a big number. I don't know what it is, but I know that 27 times 10 is 270. Okay, and then let's see, 24 times 9 minus 24 times 9. Let's see what that is. 24 times 9, 6, 3, that's 2, what, 216? So it's going to be minus some 216. And it's actually going to be way bigger than this, so we know it's going to be positive. So that's just an instance where you don't have to figure out the exact value. We just want to know whether it's positive or it's negative. So we are saying that this function is, let's see, decreasing from negative infinity all the way less than, or oh, it can't be equal to, less than x, less than or equal to 2. And the function is increasing for 2 less than or equal to x less than infinity. And let's take a look at that on the graph. Okay, remember our critical points were 0 and 2. And go to the next page. And there's the graph. And you can see, okay, from negative infinity to 0, the slope is negative. And then we found where the slope was 0. And maybe we were expecting the function to start decreasing. And so for the derivative to be, to start increasing. And for the derivative to be positive. But you can see we can hit a 0 and then still be decreasing. So we consider the function decreasing on that interval, that entire interval, even though 0, we had a 0, we had a critical point at 0. And then the function hits 2, the derivative is 0, and then it changed to positive, the derivative changed to positive, and so the function is increasing. So you can clearly see here that our function is decreasing from negative infinity all the way to 2, and then it's increasing from 2 to positive infinity. All right, I will stop there, and we'll see you next time. Becker is out.